Kylie's motorboat took 3 hours to make a trip downstream on a river flowing at 5 miles an hour. The return trip against the same current took 5 hours. We're asked to find the speed of the boat in still water. Well, the first thing I'm going to do is I'm going to create a chart. Since this is a motion problem, it's going to have rate, time, and distance. And our formula that we're used to is rate times time equals distance, which I'll end up using. And then the two situations in this problem is that Kylie is going upstream and downstream. Therefore, we have two variables that are affecting the rate of the boat. We have the actual boat in still water, which is what they're wanting to find. So I'll call this B, the boat. And then the other thing that's going to affect the boat then is the current. But they told us that the current is 5 miles per hour. So in this case, that's not a variable, it's a constant. So starting with that, I know that the rate going upstream is going to be slower. So in both cases, I'm going to start with the boat, but the current is going to affect the boat. So if I'm going upstream, it's going to subtract off the rate of the boat and make it go slower. So I have to subtract the 5. If I'm going downstream, it's going to make the boat go faster by 5 miles an hour. All right, now, looking back in the problem, let's see with the other values that go in the chart. So we know that it took 3 hours to make the trip downstream. So that's a time downstream. So I'll go ahead and put my 3 here. And then the return trip against the same current took 5 hours. So that's the time upstream. Find the speed of the boat in still water. Well, I've read all of the words, and this column here is blank. That means that the only way to fill it in then is to use the formula. The formula tells me that rate times time is equal to distance. And I'll go ahead and write the 5 first. So 5 times B minus 5 must be the distance then upstream. And same thing with our second row. If I'm going downstream, then I'm going to put the 3 first. 3 times B plus 5 must be the distance. Now we need an equation to solve. Since we only have one variable here, I need one equation. Well, since they're going up the river and then they're going back down the same river, then these two distances must be the same. So my equation then is going to be that 5 times B minus 5 must be the same as 3 times B plus 5. So I'll go ahead and solve this equation. I'll start by distributing. So we have 5b minus 25 equals 3b plus 15. I typically start with my variables to solve, so since I have fewer b's over here, I'll subtract 3b from both sides. That leaves me with 2b minus 25 equals 15. That's the 15 that's left. And then now I'll add 25 to both sides. Again, I'm trying to isolate b, so 2b equals 40. And then finally, dividing by 2, I see that b is 20. So the question asks for the speed of the boat in still water. So the boat speed must be 20 miles per hour in still water.